So this lesson's on solving inequalities. Inequalities are a lot like equalities, except we don't have an equal sign. We have symbols like less than or greater than or equal to. And besides solving these inequalities, what we'll also do is we'll be writing inequalities that are based on what's called a constraint. A constraint is something like there's a maximum number of something that you can buy, or there's a minimum height that you need to have. That minimum height or the maximum amount to spend is a constraint. We can't spend more money than we have, things like that. So first, when we read these inequalities, we try to start from the variable. So the top one, we would say that x is greater than or equal to 5. So greater than because it points to the right, and equal to because of the equal sign, because of the line underneath it. So that's a greater than or equal to, as opposed to, say, a less than or equal to symbol. Now again, starting with the variable, if I switch this around, notice that I still have to have the arrow pointing towards the variable in this case, so x is less than 3. Now let's take a minute and solve this equation that we have here. 12 minus 3x is less than 36. Solve it like an equation. So we subtract 12 from both sides. Negative 3x is less than or equal to, or just less than 24. We'll divide by negative 3. Now here's where we have to be careful. In algebra, when we multiply or divide by a negative number, the inequality sign has to flip its direction. So in this case, my x is still remaining on the left side, and the inequality is not going to be a less than, it's going to be a greater than. And 24 divided by negative 3 is negative 8. So the thing to be careful about there is if you're dividing or if you're multiplying by a negative number, you have to flip your inequality sign around. So we can even solve big old equations like this. So we have fractions. You might remember that to clear out the fraction, you multiply by the denominator. So I'm going to multiply all my terms by 3. Solving that, these 3's cancel out. So I have 4 times 4 subtract 2x is greater than 12x minus 24. Doing some distributing, 16 subtract 8x is greater than 12x subtract 24. Let's balance that equation out. Now here's something to consider as well. If you want to, I'm going to add 8x to both sides. Remember that little thing we talked about when you divide or multiply by a negative number? Well, I can control that because if I add my 8x to both sides, I'm going to get a 20x over here. And likewise, let's add 24 to both sides. 16 plus 24 is 40. And now when I divide each side by 20, I get that x is less than 2. If you want to write it the other way, so it's x is less than 2, we can do that also. So check out this bottom question for a minute. We say that the value of x is somewhere in this interval. The interval starts at 0 and goes to 4. So the integers from 0 to 4. Which are the integers that make this inequality true? Well, what are the integers that are less than 2 but still in here? That interval is going to be 0, 1, 2, 3, and 4. So which of those are less than 2? Well, it's got to be 0 and 1. So 0 and 1 are my two integers that would make that inequality true. So let's keep going. Let's take a look at like an application problem that might have some constraints on it as well. So Alexis has this gift card. It's worth $100, and she's going to buy some songs and some movies. Songs are $1.29 each. Movies are $7.99 each. So we want to write an inequality that shows the purchase of X songs and Y movies using the gift card. So we're not going to use any extra funds as well. So let's think for a minute. How much is that gift card worth? It's worth $100, right? So we know that we can't go over 100. So we can be less than $100. We could equal $100, but we can't be more than $100. Now, we're purchasing X number of songs. We're told that songs cost $1.29. So what if we said $1.29 times X? And we're also purchasing movies that are $7.99 each. So let's add $7.99 times Y. So the cost of the movies is $7.99 times Y. cost of the songs is $1.29 times X. So this equation models a constraint that we have. The combination of purchases cannot be more than $100. It's less than or equal to. So now Alexis purchased 8 movies. So can we use that to determine how many songs that she can purchase? What is her maximum number of songs she can purchase? Well, movies are the variable y. So if we substitute the y in, we get $1.29x plus $7.99 times 8, and that's less than or equal to 100. When I multiply that out, I'm going to get $63.92. So 8 movies cost us $63.92. Now we solve this inequality as we subtract $63.92 from both sides. I get that $1.29 times X is less than or equal to $36.08. When I divide both sides by $1.29, we got to take a look to see what happens here. We get that X is less than or equal to about 27.968. So let's think about that number for a minute. What's the maximum number of songs she can purchase? She can purchase 20, 22 or so. She can purchase 27 whole songs, but she cannot purchase a 28th song. That decimal, even though it's 0.9, because the X represents whole numbers of songs, we have to say that she can only purchase up to 27 songs. So this is how we use inequalities. We solve them just like equations, and we can even write some constraint type problems for them as well.